Many people around the industry believe that we are on the cusp of a major transformation in computing and content and application delivery. When computing first started, it was about a centralized architecture where mainframes were involved and the majority of the processing was done in a central location, hosting several tens or thousands of users around the same mainframe. From that point on, we moved to what we like to call Generation X, where both application and content was using a client-server model where most of the content consumption was done on-premise. So if this means that for watching a video, you had to go out to your neighborhood Blockbuster store, get that DVD, plug it into your player, then watch it in your own household. And if it was for just generic computing, you typically had like a Windows or an Oracle application that you had to consume and install on-premise inside your own enterprise. But that was the 90s, and now we're in what we call Gen Y, and we don't wear flannel shirts anymore, and we don't go Blockbuster, it doesn't exist anymore. What we do today to watch most of our application or to stream them, we go to the cloud. We use AWS, we use Netflix, Amazon, Hulu. Most of these applications are streamed from a central place, going back to the model that we used back in the day with mainframes, but now it's coming from things like Amazon Web Services or Salesforce or Netflix or various private clouds like Google Cloud. And they're all streamed to us, to our mobile devices, to our devices in the home, connected TVs, where we don't have to install very much on the device themselves. There's a new set of applications that is coming just around the corner. Things like virtual reality, augmented reality, 4K video, and autonomous vehicles. And these things require a whole new range of demands from application delivery. The centralized cloud-based delivery model does not satisfy the unique requirements of these new set of applications that are just around the corner. We believe that service providers have a tremendous opportunity in helping create a new application and content delivery model for these types of applications. There are two major challenges that these new set of applications place on content delivery. The first challenge is bandwidth and scale. If you look at things like 4K video and the encoding that is required to carry it, that's something like 10 to 20 megabits per second. Now multiply that times several users in a given household and then times the entire population of video consumers in the world, and you reach a conclusion that the current network infrastructure is only at about 5% to 10% of what is needed to carry all that video traffic. The second problem, which pertains to a majority of applications, is latency. Other applications like VR and AR require a latency for delivery that is lower than 20 milliseconds. The reason for that is that anything higher than that basically confuses your brain and you get into a condition similar to dizziness or even vertigo. So without achieving this latency, VR, AR don't really work. And you basically have to find a way to get the infrastructure in place to beat that 20 millisecond figure. Latency also matters for video. It actually matters a lot. The majority of video today is being carried over TCP. TCP is highly latency sensitive. The higher the latency, the smaller the window size that you can get, and that equates to lower bandwidth. As we mentioned earlier, 4K requires at least 10 megabits per second for transmission. So if you're not able to reduce the latency to a minimum, you're simply not going to get the bandwidth and throughput that you need to carry all those 4K videos. Now this very point is where we feel the greatest opportunity for service providers to actually play a key role in application delivery is. So remember that 20 millisecond figure that we mentioned. We call this a quilt, the 20 millisecond zone. So what we have here is a typical service provider network starting at the core, the aggregation, the access, and the actual consumers all the way at the bottom of the diagram. Now the way content is delivered today, in most instances, you have some CDN, some content delivery infrastructure over there at the cloud that is getting their content into the service provider network by using either peering or transit to connect to the service provider side. Now these CDN POPs are typically a distance of 500 to 1,000 miles away from where the actual consumers lie, and what this equates to is very high latency, relatively speaking. Latency, as you all know, correlates directly to distance. The further you are from the user, the higher the latency, and the closer you are, the better that you can get. So our goal is to actually bring content a lot closer to where the user is, and by doing that, reduce the latency to the minimum possible. So our target figure is 20 millisecond. And the places that are typically achieve that number are about 100 miles or closer to the user. This is where we feel there's a major opportunity for service providers. If you think about places that can achieve this 20 millisecond and who owns infrastructure in that range, service providers are the key entity. They own network infrastructure, and they also own customer premise infrastructure inside the homes. Both of these can serve as elements in content delivery. So now the key question is, how can service providers leverage this infrastructure that they have and become a key part in content delivery? And this is the part where Quilt can help service providers with our newly launched Open Edge Cloud platform. Our Open Edge Cloud platform creates an extension of the existing centralized cloud-based infrastructure deep inside the service provider network. And there are 5 principles that compose this Open Edge Cloud platform. The first principle is that this is software. The software that we're running is run over massively distributed computing infrastructure deep inside the service provider network and across multiple service providers around the world. The second principle is that the platform runs over common compute infrastructure deep inside the service provider network. The third and most important principle is that there is an open API that's reflected from within the service provider network into the entire publisher and CDN infrastructure so that these entities can actually leverage the Open Edge Cloud platform. The fourth principle is that the infrastructure actually tailors itself to the applications being used. So if there's apps that require heavy bandwidth and a lot of storage, we're going to allocate storage for them. But if there's other apps that require very low latency and fast processing, but not a lot of storage, we can do that as well at the same time. The final principle is that this infrastructure is actually complementary to the centralized cloud. So we do not believe that the centralized cloud is going away anytime soon. So the way we see this evolving is essentially a divide and conquer approach where the centralized cloud does and takes a bulk of the processing, and the edge cloud is using for delivery and distribution of the latency sensitive and bandwidth intensive content from a distance very close to the end user. Over the last couple of years, we've been working hard at creating the Open Edge Cloud platform that enables service providers to basically open up their edge cloud infrastructure and enable content providers, publishers, and CDNs to leverage and delegate content into the edge cloud and enable delivery at very low latency. If you're a service provider, we believe the 20 millisecond zone creates a tremendous opportunity that's unique only to you. It can actually become one of your most strategic assets, greater than any one specific access technology. The 20 millisecond zone is something you need to own.